Have you ever stepped outside on a completely dry day, taken one breath, and thought, it's going to rain? Not because you checked the forecast. Not because the sky was dark. Not because your left knee received a weather alert from the spirit realm. The air just smelled like rain. Which raises a fairly obvious question. If the rain hasn't arrived yet, what exactly are you smelling? Rain can't send its scent ahead to reserve a table. Water vapor doesn't smell like wet dirt. And unless your nose has quietly installed a radar system, you shouldn't be able to smell something that hasn't happened yet, right? But people really can smell rain before it starts. The trick is that you usually aren't smelling rain from the future. You're smelling evidence that rain has already started. Somewhere else. The smell we call rain isn't one smell. It's several smells that tend to arrive in the same trench coat, hoping nobody asks for identification.
Who's that?
There's the earthy smell of wet soil. And around thunderstorms, there can be a sharper, almost metallic or electrical smell associated with ozone and other atmospheric chemistry. Your brain bundles all of that together and labels it rain. But the most famous part of that bundle is called petrichor. Petrichor is the earthy scent that appears when rain hits dry ground, especially after a long dry spell. But petrichor isn't a substance sitting in a puddle waiting to be sniffed. It's more like a chemical mixtape. During dry weather, oils from plants and other organic compounds can collect on soil, rocks, pavement, and other surfaces. Meanwhile, the soil is full of microscopic life. One important group is streptomyces, bacteria that live in soil and produce a compound called geosmin. Geosmin literally means earth smell. It's responsible for much of that deep, damp, freshly turned soil scent. It's also part of the reason beets taste earthy. So if you've ever eaten a beet and thought, why does this taste like somebody buried it? You've already met geosmin. Geosmin can also make drinking water or fish taste muddy, which means the same molecule can be beautiful after a summer storm and deeply suspicious inside a glass of water. Context is doing a lot of work here. And the human nose is astonishingly sensitive to it.
We can detect geosmin in the air at concentrations of only a few parts per trillion. That's the chemical equivalent of someone whispering dirt from another county. But how does a chemical sitting in the soil suddenly get launched into the air? This is where raindrops become tiny aerosol machines. Researchers have used high-speed cameras to watch individual drops strike porous surfaces, such as soil. When a raindrop hits the ground, it can trap microscopic pockets of air beneath it. Those bubbles rise through the drop and burst at the surface. When they burst, they fling extremely small droplets and particles into the air. Those airborne particles are called aerosols. They can carry geosmin, plant compounds, material from the soil, and even microorganisms. So one raindrop hits the ground, traps bubbles, and then fires a microscopic perfume cannon into the atmosphere. The smell of rain isn't simply evaporating upward, it's being physically launched. This also explains why petrichor can be especially strong when light or moderate rain first hits dry, porous ground. The conditions have to be right for the bubbles to form and burst efficiently. When rain is absolutely hammering the ground, the drops may strike too quickly and violently for the same process to work as effectively. But those first drops on thirsty soil, that's the opening of the bottle. Now we've reached the important part. If those particles are released only after rain hits the ground, how can you smell them before rain reaches you? Wind. Suppose a rain shower is moving toward you. The leading edge of the storm may push air outward and ahead of the falling rain.
Rain is already hitting soil a few miles away, producing aerosols loaded with earthy-smelling compounds. The wind carries those compounds toward you before the rain itself arrives. Your nose receives the trailer before the feature presentation. So when you say, I can smell rain coming, you may be completely right. But your nose isn't predicting the rain. It's detecting the rain's distant consequences. This is the same basic reason you can smell a barbecue before you can see the grill. You aren't predicting hamburgers. The hamburgers have already happened somewhere upwind. The rain version just feels more mysterious because the source may be hidden beyond trees, buildings, or the horizon. And because nobody has ever stared solemnly into the distance and said, "A cookout approaches." But petrichor is only one version of the pre-rain smell. Thunderstorms can bring a different scent. Some people describe it as sharp, clean, metallic, chlorine-like, or electrical. That smell may involve ozone. Normal oxygen in the air usually travels in pairs of oxygen atoms. Ozone contains 3. Electrical activity and atmospheric chemical reactions can help produce ozone higher in or around a storm. Thunderstorm downdrafts can then carry ozone-rich air downward and outward, where a human nose may detect it before the rain arrives. So the storm has 2 possible advance teams. Near the ground, wind can carry petrichor from places where rain is already falling. Higher in the atmosphere, storm circulation can bring down air with a different chemical character. Your nose doesn't identify the individual molecules and submit a laboratory report. It just notices that the air has changed. Then your brain compares that change to every storm you've smelled before.
That last part matters because smelling rain is partly chemistry and partly pattern recognition. You may also be noticing cooler air, stronger wind, changing light, leaves turning over, or distant thunder. Some of those aren't smells at all. But your brain is an enthusiastic editor. It combines multiple clues, cuts out the boring explanation, and hands you one confident thought. I smell rain. This is why the ability can seem almost supernatural. You aren't consciously listing the evidence. You're receiving the finished conclusion. It's the sensory version of walking into a room and knowing somebody has been eating popcorn. You may not see the bowl, you may not hear any chewing, but the room has confessed. There's also a reason the first rain after a dry period often smells strongest. During dry weather, plant oils and other compounds have time to accumulate on surfaces. Geosmin and related material remain in the soil. Then the first drops arrive and release what's been building up. Later rain may still smell pleasant, but the opening burst has already spent much of the chemical savings account. But the surface also matters. Dry soil, clay, rocks, vegetation, pavement, and concrete can each contribute different compounds and different versions of the smell. A rainstorm in a forest doesn't smell exactly like rain on a hot city street. A desert storm can smell strongly of plant oils. Rain on pavement can release accumulated oils, dust, and organic material. So there isn't one universal bottle labeled rain scent. Every landscape is remixing it. This also means not everyone will smell rain at the same time, even when they're in the same general area. The wind may carry the scent through one neighborhood and miss another. Or one person may be more sensitive to geosmin than another. And sometimes the smell isn't followed by rain at your exact location at all. That doesn't necessarily mean your nose was wrong. The shower may pass nearby. The wind may carry the scent from rain that never reaches you. You smelled a storm. It simply failed to complete the delivery. There's a popular explanation that humans are so sensitive to geosmin because our ancestors needed it to find water. It's a wonderfully tidy story. Rain smell leads to water. Water keeps humans alive. Therefore, evolution gave us a geosmin detector. That's possible, but possible isn't the same as demonstrated. Humans are highly sensitive to geosmin, but the exact evolutionary reason isn't settled. Our attraction to the smell may involve experience, memory, culture, relief from heat or drought, or several things at once. The science can explain how the odor reaches us much more confidently than it can explain why so many of us enjoy it. And not everybody does enjoy it. Some people find petrichor comforting.
Others think it smells musty, moldy, or dirty.
Ew.
Geosmin itself doesn't have any obligation to be poetic. That part happens inside us. A molecule made by bacteria enters your nose.
Your brain attaches memories of open windows, dark clouds, childhood summers, wet gardens, hot pavement cooling down, or the relief of a storm finally breaking the heat. The chemical is tiny. The memory it unlocks can be enormous. So, can you actually smell rain before it arrives? Yes. But the answer is more precise than it first appears. You can't smell rain that hasn't happened. You can smell compounds released where rain has already begun. You can smell aerosols created when raindrops strike dry ground. You can smell geosmin made by soil microbes and oils collected from plants. And before some thunderstorms, you may detect ozone-rich air carried downward and outward by the storm. Your nose isn't a weather satellite. It's a chemical receiver with an absurdly low detection threshold and a brain that's very good at connecting clues. You aren't smelling the future. You're standing downstream from a message. The soil has been struck by rain. Microscopic bubbles have burst. Invisible particles have lifted into the wind. And miles away, before the first drop touches you, your nose reads the message and says, "It's coming." If there is a strange question you cannot stop thinking about, leave it below. It might become a future video. And if you liked this video, check out Why Don't Woodpeckers Get Concussions?